Have you ever wondered why a leaf changes color in the fall, or why an apple turns brown when you cut it open? These everyday mysteries are not the work of magic but the result of the fascinating world of chemistry that surrounds us. You see, chemistry is not confined to laboratories or textbooks. It's in the air we breathe, the food we eat, and the colors we see. It's a part of our everyday life, subtly shaping the world around us in ways we often take for granted. Take the example of leaves changing color. During the warm, sun-soaked months of spring and summer, leaves are a vibrant green due to a chemical called chlorophyll, which helps plants absorb sunlight and convert it into energy. However, as the days grow shorter and cooler in the fall, the production of chlorophyll slows down. This allows other chemicals like carotenoids and anthocyanins to show their colors, resulting in the beautiful red, orange, and yellow hues we associate with autumn. Or consider an apple. When you slice into a fresh apple, the flesh is typically a crisp, juicy white. But leave it out for a while and you'll notice it starts to turn brown. This is due to a chemical reaction known as enzymatic browning. The moment you cut into the apple, you're breaking cells open, allowing oxygen in the air to react with an enzyme called polyphenol oxidase, and voila! Your apple starts to brown. These are just two examples, but the reality is, chemistry is happening all around us, all the time. It's in the baking soda reacting with vinegar to make a volcano for your child's science project. It's in the rust forming on an old bicycle left out in the rain. It's even in the glow of a firefly on a summer night. So the next time you see a leaf change color or an apple turn brown, remember it's all chemistry. So, what makes up everything we see, touch, and feel? It's all about atoms and molecules. Now, atoms and molecules might sound like complex terms, but let's break them down into simpler ideas. Imagine you're building a Lego castle. Each Lego brick represents an atom, the smallest unit of a chemical element. These bricks, or atoms, are incredibly tiny, so much so that millions of them would fit on the head of a pin. Atoms are like the alphabet of the universe. Just as you can arrange 26 letters in countless ways to form words, sentences, and stories, you can arrange atoms in countless ways to form all the different substances in the universe. Now, what happens when you put these Lego bricks or atoms together? You build a structure, right? In the world of chemistry, these structures are called molecules. Molecules are simply groups of two or more atoms bonded together. Let's use the example of water, which we know as H2O. This is a molecule made up of two hydrogen atoms, those are the H part, and one oxygen atom, that's the O part. These atoms are bonded together to form a water molecule. When you take a sip of water, you're not just drinking hydrogen or oxygen. You're drinking millions upon millions of water molecules, each made up of two hydrogen atoms bonded to one oxygen atom. And it's not just water. The air we breathe, the food we eat, the clothes we wear, they're all made up of atoms and molecules. These tiny particles are constantly interacting, combining and recombining in different ways to make up the world as we know it. So, the next time you take a sip of water or breathe in the air, remember you're interacting with atoms and molecules, the basic building blocks of everything around us. Whether it's the water you drink or the air you breathe, atoms and molecules are the basic building blocks of everything around us. You might be wondering, how do these atoms and molecules interact with each other? Well, let's dive into the fascinating world of chemical reactions to answer that. At its core, a chemical reaction is a process that leads to the transformation of one set of chemical substances into another. It's like a well-choreographed dance where the dancers, or in this case atoms and molecules, change partners to create a new dance formation. Now imagine a room filled with hydrogen and oxygen atoms. If we bring a spark into the room, these atoms don't just continue floating around independently. Instead, they interact in a very specific way. Two hydrogen atoms partner up with one oxygen atom, and voila, a water molecule is formed. This is a classic example of a chemical reaction, but how does this happen? It's all about the electrons. Each atom has a certain number of electrons in its outer shell, and in chemical reactions, these electrons are attracted to the electrons of other atoms. When the attraction is strong enough, the electrons can move from one atom to another, and this rearrangement results in the formation of new substances. In our hydrogen and oxygen example, the oxygen atom shares its electrons with the hydrogen atoms, creating a bond that holds them together. And just like that, we have water. But here's the real kicker. Not only do we have a new substance, but this reaction also releases energy in the form of heat and light. That's why we see a flame when the reaction occurs. So, the next time you see a flame, remember it's not just a pretty light, it's a visual manifestation of a chemical reaction, a testament to the incredible dance of atoms and molecules. And if you think chemical reactions are limited to laboratories and science experiments, think again. They're happening all around us, all the time. Every breath you take, every meal you cook, even the simple act of boiling water involves chemical reactions. So every time you boil water for your coffee or tea, a chemical reaction is taking place right in front of your eyes. Now let's dive a little deeper into the world of atoms. Where do we find details about these atoms? Well, ladies and gentlemen, welcome to the periodic table. Think of it as a grand library of atoms. It's a chart that houses all known atoms, organized meticulously based on their properties. It's a bit like a cosmic directory, if you will, where each atom has a unique address based on its characteristics. Now let's imagine the periodic table as a colossal mansion with more than 100 rooms. Each room, in this case, represents an element. And in each room you'll find a single type of atom that defines that element. The mansion, as a whole, represents our universe, and the rooms are the building blocks that make up that universe. Let's take a stroll through some of these rooms. First, we enter the hydrogen room. It's the first room in the mansion, signifying that hydrogen is the lightest and simplest element. It has only one proton and is the most abundant element in the universe, making it an essential player in the story of matter. Next, we walk into the oxygen room. Oxygen, with 8 protons, is a life-sustaining element. It's essential for respiration and combustion. It's like the breath of life in our cosmic mansion. And finally, we step into the carbon room. Carbon, with 6 protons, is the key element in organic compounds. It's the foundation for life as we know it. The carbon room is like the heart of our mansion, pumping life into every corner. Remember, the periodic table isn't just a static chart, it's dynamic and continually evolving as we discover new elements. Each time a new room is added to our mansion, it enriches our understanding of the universe's building blocks. As you can see, the periodic table is not just about science, it's about life, the universe, and everything in it. It's a testament to human curiosity and our relentless pursuit of knowledge. The periodic table is like a cheat sheet for everything we know about atoms. Indeed, it's our guidebook for navigating the fascinating world of atoms and elements. So why should we care about all this chemistry stuff, you might ask? Well, let's dive right into it. Chemistry is all around us, interwoven into the fabric of our daily lives. It's in the air we breathe, the water we drink, even the food we eat. Understanding chemistry can provide valuable insights into the world around us. Take medicine, for instance. Many life-saving drugs are the result of intricate chemical reactions. Chemotherapy drugs that fight cancer, painkillers that alleviate suffering, antibiotics that ward off infections, all are products of chemistry. By understanding how these substances interact with our bodies at a molecular level, we can develop more effective treatments and even potentially cure diseases. And what about food? Chemistry plays a starring role here too. The delicious aroma wafting from a freshly baked loaf of bread, the delightful fizz of a carbonated drink, the rich flavor of a perfectly brewed cup of coffee. These are all the results of complex chemical reactions. Knowledge of chemistry can help us make healthier food choices and understand why certain foods taste the way they do. In the realm of technology, chemistry is a key player. From the lithium-ion batteries that power our smartphones and electric cars, to the semiconductors at the heart of our computers, chemistry is at the core. By understanding the chemical properties of materials, we can create more efficient, sustainable, and powerful technologies. But the importance of chemistry extends beyond these practical applications. It's a tool for problem solving, a way to understand the world at its most fundamental level. It helps us make informed decisions about everything from what we eat to what products we use, to how we can best protect our environment. From the food we eat to the technology we use, chemistry plays a crucial role in our daily lives. It truly is the central science.